Okay, so here I have zinc, and it's neutral. It's not combined with any other element. If I'm following our steps that I've written over here, to balance these, the very first thing I do is assign oxidation numbers. So because this is neutral and it's not combined with any other element, its oxidation number is 0. If something has a charge, that is its oxidation number. Because the whole point of assigning oxidation numbers is to figure out hypothetical charges for things that don't normally have charges. This does have a charge though, so we don't even have to be hypothetical. That's its oxidation number. That means this one's +2 and this one's 0. Okay, step 2 is to draw brackets between elements that change their oxidation states. So I see zinc before and after the reaction changed. It went from a 0 to a +2. And we gotta think, what happened to that? What was the change? Did it lose electrons oxidation or did it gain electrons reduction? Well, yes, the number got bigger, but you have to remember electrons are negative. So if you get more positive, that actually means you lost negative electrons. So this is going to be called oxidation. And so I'm doing step 3 right now. I'm writing down that this was oxidation. That means copper must have been the thing that was reduction or got reduced, because you always have both of them simultaneously. That's why we call it redox. You can't just have one or the other. You'll always have something that was oxidized and something that was reduced. Okay, step 4 is to figure out how many electrons were transferred in this reaction. Zinc went from 0 to +2, so it lost 2 electrons. Copper's ion went from a +1 to 0, so it gained 1 negative electron. Remember, Leo says grr to help you remember redox, reduction and oxidation. Okay, problem is that even though these elements look like they're balanced, like how we would balance before, there's only one zinc, one copper, the change in electrons isn't balanced. Here it looks like zinc lost 2 electrons, but this copper only picked up 1 of them. So if we leave it as is, it looks like we lost an electron. Like, where did the other electron that went away from zinc go? But if we follow these steps, we're going to actually balance that charge so we don't lose track of any electrons. To do that, our goal is to make both of these numbers the same, the number of electrons that were transferred. So if I multiply this by 1, this number will still be 2. If I multiply this by 2, I make it 2 and 2. They're the same if we multiply by those numbers. Finally, that's not really doing anything, just by writing the brackets. We actually have to multiply in the equation. So anything connected with this bracket needs to be 1. 1, 1. Anything connected by this bracket needs to be multiplied by a 2 or have 2 of them. So I'm going to put a 2 here. Now we double check step 6 that every element is balanced. Well, we already checked at the beginning, they were already balanced. 1 zinc, 2 coppers, 2 coppers. This now works, the electrons are balanced, because it means that yes, that we have 1 zinc and it gave away 2 electrons. It gave away 1 electron to one of these ions to form 1 neutral copper. It gave away its other electron to another set of these to form a second neutral copper. And now everything's balanced electron-wise. So your final answer will be 1, 2, 1, 2. Here I'm going. We're getting a little bit more complicated for oxidation numbers. There's some rules you can memorize. I know hydrogen's always +1. And there's 2 of these, so you can think +1, +1, that's a total of +2. It's a neutral compound, so this all has to add up to 0. So whatever sulfur is, has to add up to 0, it has to be -2 to balance that out, because there's 2 of those +1s. This is an element not combined with any other element. Yes, it's combined with another chlorine, but you're looking for ones that are in compounds with other elements that aren't like it. So this is still 0. 0, not combined with another element. Hydrogen's always +1, so to balance it out, chlorine must be -1 here. Okay, now we gotta draw brackets to connect things that changed. So hydrogen was +1 and +1, so it didn't change, but sulfur changed. If we draw a bracket here, we can see that sulfur went from a -2 to a 0. This is probably the hardest part, figuring out if this is oxidation or reduction. It was negative, and it got more positive, so it must have lost negative stuff. It lost the electrons, that's oxidation. So I'm going to write OX for oxidation. Chlorine, then, was the thing that must have been reduced. Let's double check. It went from 0 to -1, so it did get more negative. It gained negative electrons, so that's reduction. I'm going to write reduction red for short. Okay, now we gotta figure out how many electrons did it lose in this oxidation process. Well, it went from a -2 to a 0, so it lost 2. This one went from 0 to -1, so it gained 1. Okay, so we're not balanced electron-wise yet. This is why we have to do step 5. We have to multiply to get these numbers the same, to get the same number of electrons lost as we have gained. So what if we make them both 2? Then we'll be balancing out our electrons. So the trick is to have anything connected to this bracket needs to be exactly the number in the parentheses. So we already have 1 sulfur. We're trying to make everything in this bracket now 2. We have 2 chlorines because of this subscript 2, so we do not want to add anything here or put any coefficient here. We only have 1 chlorine here, so we gotta put a 2 there. Okay, we followed everything. This would be a lot of points on the test if you can get this far. Finally, we have to balance elements like normal. So double check that everything's balanced. So 2, 2, 1, 1, 2, 2. We're good. So that would actually be 100%. Okay, step 1, assign oxidation numbers. This is where it gets a little trickier to do with oxidation numbers. So you gotta go step by step. Oxygen is always -2. Okay, so if I wanted to, I could say there's 4 oxygens. So let's figure out how much negative charge is really coming from these oxygens. 2, 4, 6, 8 is coming from here. A lot of people get stuck at this point because they say, well, I don't have a rule for copper or sulfur. That's always true. I look at this, I see that there's a polyatomic here. Sulfate's a polyatomic. I know that this is an ionic compound. Anytime you have a metal and a non-metal, or a metal and a polyatomic ion, that's an ionic compound. That means their normal charges still apply. Like if we're thinking, you know, what if this dissolved in water, what would it break into? It would break into copper +2 and sulfate -2, because we know sulfate's charge is -2, so to balance it out, copper must be +2. And so it is, because this is an ionic compound, their normal charges apply. It just gets a little bit weird when we're trying to think about sulfur, because all we know is sulfate is -2 total. So this is where we have to do some little math. So this is -2 again, it's oxygen. We have 4 of them. I'm just gonna write that again. So that's -8. We know copper's +2 to balance out that -2 total from the sulfate. So +2, I can carry that down. And we don't know what sulfur is, so I can carry that down, that's X. We know that total they have to add up to 0. So 2 minus 8 is -6. And we still have X there, and if we plus 6 over on both sides, we'll get X must be +6. So it looks like sulfur is +6. So that was a trickier one. You had to solve for the sulfur there. This is an ionic compound, so I can think like, oh, I know alkali metals are always +1, that's one of our rules. Or you could think it's an ionic compound, it's the normal charges they have that we're used to, that we memorized our periodic table. Alkali metals +1, halogens -1. Same thing here, it's an ionic compound, so we know halogens are always -1. This is a transition metal, so it could vary, but I can tell that it must be +1 if it has to add up to 0. This is not combined with any other element, so it's 0. Again, oxygen is always -2, alkali metals are always +1, and now we have to solve for sulfur. So I can go -2, -2, -2, -2. I did 4 -2s because each of these 4 oxygens are -2. That's a total of -8. Each of these potassiums, because it's an alkali metal, is +1, so that's +2. And then I don't know sulfur again, so I'm going to put in X. Okay, and that has to add up to 0, which if you do the math, it's very similar to the one we just did before. It must be a +6 that goes there to make it 0. Whew. Okay, so that was a little bit trickier, but that's how you find all the oxidation numbers. Now we gotta connect with brackets the things that changed. I see right away that copper changed. Copper went from a +2 to a +1. So it got more negative. Yes, it's still positive, it went down. So it got more negative, which means it gained electrons. I'm gonna call that reduction. How many did it gain? Well, 1, because it went from a +2 to -2. Sulfur stayed at +6. Oxygen the whole time was -2. Potassium stayed at +1, so it must have been iodine. Yep, iodine changed here. Notice how there's iodine in 2 places. I don't want to connect these two because it didn't change this element to this element. It changed iodine here from -1 to 0, which means it lost electrons 1. Oxidation, lose electrons, oxidation. Okay, so they're already the same number. So let's just check. 1, 1. So everything connected with this bracket needs to be 1. So we have 1 copper, 1 copper. We need everything in this bracket to be 1. We have 1 iodine. We have 2. Okay, so it looks like we're going to have to put a sneaky 0.5 right there. Okay, so that's a 0.5. You can't read that. Because 0.5 times 2 is 1. We're forcing anything that's connected to this bracket to be exactly the number that we use to balance out the electrons. If you want to, you can think about, we have to take this times 1 and this times 1, okay? It's 1, the number in the parentheses, to make them the same. Then, we can't forget, after that, you have to balance elements like normal. So copper, we have 1, 1. Sulfur, 1, 1. Oxygens, I have 4, 4. Potassiums, I have 1 here, though, and 2 here, there. So I'm going to make that a 2 to balance it out. Now I have 2 iodines here, and I have 1 here. Remember, this is 1 total, so 2. Okay, so everything's balanced, but we don't like to have decimals in our final answer. So what we do is we multiply everything by 1. So remember, there's an invisible 1 here. So this is going to become 2. This is a 2. So this is going to become a 4. There's a 1 here, so this becomes 2. 0.5 times 2 is 1. So I'm not going to write it once. And there's a 1 here, so that becomes 2. So right away, I'm seeing this. Hydrogen, write it plus 1. Hydrogen is only minus 1 if it's with a metal. Carbon's a non-metal. Okay, and we will rarely see hydrogen with a metal. And there's 6 of these. So 1, 2, 3, 4, 5, 6. So a positive 6 charge total. I don't know carbons right now, so I'm just going to write 2 X's. There's 2 of them. So that means 2x. I'm bringing this down. This has to add up to 0. So 2x, move that 6 over, it'd be a negative 6, divide by 2. X must be negative 3. So to balance that out, each of those carbons must be negative 3. Oxygen's not with any other element, so I'm going to write 0. Oxygen here is minus 2 because it's oxygen, and there's 2 of them, so that's a total of negative 4 charge. So whatever carbon is here must balance out, so that must be plus 4, because we're trying to make that equal 0. This is minus 2, so each of these must be plus 1. Okay, now we got to connect what changed. As I'm looking here, I see carbon change, so let's connect carbon. I'll use this. Okay, carbon with a bracket. This is a little tricky. It went from a negative 3 all the way to a positive 4. That's a difference of 7, and it got less negative, so it lost electrons. That's oxidation by 7. Here, oxygen, watch what happened. I could draw this, right? It went from 0 to minus 2. But what's stopping me from wanting to draw the arrow like this? Because it also changed here. So sometimes an element is going to have one oxidation number, and then it's going to have a different one in 2 different places in your products. So the trick I like to do is I like to just kind of have a branch off of it here, because it changed in 2 places. And this is our reduction, because it gained, it got more negative. Don't think about like it gained in 2 places, so it's a total of 4, just say, compare 2 of them here. So 0 to minus 2 is 2. Okay, we gotta make these the same numbers to balance out. So there's no easy way to multiply this by something to make it 7, or this by something to make it 2. So we gotta go up. We gotta find their least, lowest common denominator, multiple. Yeah, LCM. Okay, if we multiply this by 2 and this by 7, we'll get 14 each. That's what we want. Just want to have the electrons balanced so that the same number of electrons gained equals the same number of electrons lost. Can't lose any electrons and can't go poof in the universe. This means that we need 2 of whatever is connected to this bracket. Whatever's in parentheses, we need 2 of those. We already have 2 of them. Don't put a 2 here. It's not that you put whatever's in parentheses in front. You just need that many of that element. We already have 2 carbons. We don't have 2 carbons here, so I'm going to write 2. Okay, looking here, we have a 7. So we need exactly 7 right here. So I'm going to actually have to use a decimal again to get exactly 7. If I put a 7 here, that's exactly 14. We want exactly 7 right there. So I'm going to put 3.5. And then, this is a weird one. Because it's split on this side, we want 7 total for our oxygens on this side. We already have 4, because 2 times 2 is 4. If we just add 3 more, we'll have 7. Then we gotta check that every element is balanced like normal, so 2 carbons, 6 hydrogens, 3 times 2 is 6 hydrogens, 7 oxygens, 2 times 2 is 4, plus 3 more is 7 oxygens. Okay, now we gotta double everything, because everything's balanced, but I don't like to have a decimal point in my answer, so this is 1. We're gonna double that and make that 2. 3.5 times 2 would be 7. 2 times 2 would be 4. And 3 times 2 would be 6. And that's our final answer. First things, we gotta figure out our oxidation numbers. So, oxygen is -2. If you're getting quick at these, you know alkali metals are +1, and there's 3 of these. That's a total of a -6 charge coming over here, so we need 5 more, so a +6 to balance out. -1, +1, -1, +1, 0, 0, -2, +1. Okay, now you gotta see what changed. Potassium didn't change. Bromine did though, so let's connect that with a bracket. This increased, or it gained 5 negative electrons because it went down. So I know it got more negative, so that's reduction if it gains electrons. Oxygen stayed the same, hydrogen stayed the same, chlorine stayed the same here, but it changed here. So let's connect those two where it changed. In that process, it lost an electron, so that's called oxidation, and it lost 1. We need these numbers to be the same, so I'm going to multiply this by 1 to make it 5, this by 5 to make it 5. Now they're both the same number. That balances out our electrons. Anything connected to this bracket, so these 2 bromines, need to be 1. I have 1 here. I have 2 here. I need it to be 1. I need it to be that number in the parentheses, so I'm going to multiply this by 0.5, because 0.5 times 2 is 1. Anything connected to these brackets needs to be exactly 5. So I'm going to write a 5 here, and I'm going to put a 2.5, because 2.5 times 2, so 2.5, is 5. Okay, we've done steps 1 through 5. Now we have to balance elements like normal, because this is just a starting off point to help you balance very difficult equations. So I'm saying 1 potassium, 1 bromine, this is 1, remember 0.5 times 2, 1 bromine. 3 oxygens, need 3 oxygens. I'm going to write 3 here. See, 5 hydrogens, but we just made this 6. So we never want to go down. I don't want to make this 5 because that's not going to help me here. So let's go up. Let's now change the hydrogens over here to 6. Okay, and we'll come back. So then 6 chlorines. Let's see. So 1 chlorine, 5 chlorines, because 2.5 times 2, that's 6 chlorines. Hey, I think everything's balanced. Yep, so if you get your answer and you have decimals that are halves, you gotta multiply everything by 2. So there's a 1 here, so 1 times 2 is 2. That makes 6, 12. This is a 1, so this becomes 2. 0.5 times 2 is just 1, so you could write a 1 if you want, or you could leave it blank. And then 2.5 times 2 is 5, and don't forget to multiply this last one, this would be 6. So your last answer would be 2, 12, 2, 1, 5, 6.